Hey, oh, geez, I can't see. I can't see. Oh, there you guys are. All right. Hey, hi. Check it out. We're on the chain rule, you mathematicians. So the chain rule comes when like you're putting things together in a function that's of all right. Oh, geez, I can't see. I can't see. There you go. Heck, there you are. I can see. Float on top. There we go. All right. Hey, dudes. We're checking out the chain rule today. Sweet. I know you've been waiting for it. Mathematicians, here we go. So sometimes you see complex functions that are like put together. They're not just this plus that. And we can break them apart into smaller bits and think about them as a composition of functions. And then there's a sort of a technique that's called the chain rule to do that. So if you look at this is x squared minus 2x all to the fourth. You could think about that as the outer part. This part is being one function, right? So some stuff to the fourth power. And the sum stuff, maybe we'd call u. You often see this notation with u. And u is all of this stuff in addition to u. So then therefore the stuff inside the u is the guts. Right? So I'm going to leave it as g of x and f of x. In the text, I'll show you the notation with the u. That works too. It just makes I think it's easier to see like this. So you could think about this original function y as f of g of x, right? You take g of x and you put it in there, right? You take g of x and then put it to the fourth power. Same sort of thing here. This you could maybe rewrite like this. 4 times all of this stuff, right? The radical makes the half. This radical really is the half. And because it's in the denominator, we can, that part, actually I should probably do it in a different color, but that's okay. That makes this negative. So now you can think about this the same way, right? You could think about this as the outer function is 4 times a bunch of stuff to the negative a half. That's all this red bit, right? This. And the guts is the inside, and we call that a different function, g of x. Cool. And so really, this is f of g of x also. Cool. Because we'd be putting g of x in place of that. Ooh, people coming. Quiet down. All right. So I think the hardest part of this is just figuring out what is a composite function, and what's not. So this, you can think about it as a composite function because you could call it u squared, and you could call the guts, you could say u is x plus 3, right? Or alternately, maybe you could think about it as the outside is f of x, and that's x squared, and the inside is g of x, and that's a different function that's x plus 3. So this one you could treat like a composite function. This thing's the same thing, but it's a product, right? It's not a composite function. It's just 2 functions being multiplied. Use the product rule on it. This sine of x is just a regular function. No, this is a composite function because it's sine of 2x. Anytime you hear the word of, often you think that it's a composite function, right? So the outside is the, you can think of f of x as sine of x, and the inside is 2x, right? The g of x is 2x. So 2x. So yeah, composite function. This composite function, yeah, you gotta do the cosine first and then throw it into the sine, yeah. This is just a product. Use the product rule now. Cool? Aight. So, well, I wonder if I'd look good in hair like that. Maybe. Let's try it out. If we're trying to develop the chain rule, so if we expanded this, you could call it this, right? I want to figure out a rule so I don't have to expand this, so I can just throw this into an equation and get the derivative of it. But let's find the pattern by expanding it, and then we'll see the connection. So this is 3x plus 1 squared, so it's just 2 of them multiplied together. And so if you expanded this even further, you'd get that. Right? Okay, not a problem. If you took the derivative of this, right? You'd get 2 times the 9 gives you the 18, and the exponent decreases by 1, so this is a 1, and then this is 6 times 1, so the 6, and the exponent decreases by 1, so x to the 0 is just 1, so that's why you don't see it, and the derivative of a constant is 1. Sorry, 0, because it's just a flat line with 0 slope there. Cool, so there's the derivative. Hopefully that's not too far out for you at this point. If you rewrote, like this is done, that derivative is done. But I want to be able to get from here to here without expanding this, because I know that not all of you like the binomial expansion stuff, right? I don't want to have to do that. And we can apply it to other things. So I might rewrite this like this, factor out of 6, and then also I might think about it like this. Instead of calling it 6, I'm going to call it 2 times 3, and remove the 3 to the other side. If you look at it like that, you could think about it like this. I started here, this is this piece, and I got here. I ended up here. That's this piece, right? So I took this, and here's the derivative. If you kind of piece this apart, this chunk is the derivative of the outside, but we keep that inside, right? And so that's why I colored the 2 parenthesis to the 1 a little darker red, because it's a darker derivative, right? But we keep the inside light blue. This is the derivative of the guts of the inside, right? It's 3 times 1 is 3. There's the 3 plus the derivative of the 1, which is just 0, so it's just 3. It's darker because it's the derivative. It's dark, right? So this part is the derivative of the outside, the derivative of the outside with the inside guts. I'll write this in a more specific way, right? Here's the inside guts, this part, and then multiply by the derivative of the guts. Okay, so here's how it's written often in the text, right? Y equals GU, and U is f of x. All right, right, we can see the composition of functions because U is right here, U is f of x, so this is G of f of x, or you could switch them around. Then the derivative of that is dy du du dx, right? Confusing. Once you have a deeper understanding of calc, this makes sense, and we'll talk about that in a second. But this is the notation that I like. Oh, yeah. Here's the notation this isn't my notation. This is just notation that I prefer. So it's G's preferred notation. But if you have this, right, your equation is a composition of functions, f of g of x, then the derivative of that is the derivative of the outside, this piece, keep the interior, and then multiply by the derivative of the interior. Cool. This says the same thing, right? If you have a function, right, and there's a function inside and you have another power, right, if you have a power outside, then you do the derivative using that power but keep f of x inside, and then do the derivative of the inside. It's just a repercussion of this. So that sounds crazy, but let's use it, right? So this is still right here. So this means find the derivative if you have this. Okay, well, we figured out back here that this thing you call one function the something to the fourth, and the other function the inside, the guts. So let's look back here. If you thought about, I don't know how they have this written. So there's our original function. You'd say, all right, well, one of our functions is u to the fourth, and this is u, right? And that's what they said here. So you've got 2 functions sitting there. They said now, and they described the chain rule. Thanks. But like, we don't need to talk about the chain rule every time. So this is really like saying the derivative of the outside, they keep u and we'll replace it in a second. and then they take the derivative of the inside, right? Multiplied by the derivative of the inside. The derivative of the inside is 2 times x to the first, that piece. And then this is a 1 you multiply. So there's the derivative of the inside. And then later they replace the inside. This piece they replace here, and now we're done. Maybe they clean it up, maybe they don't. No, they don't. If I was working this myself, I would not write it like that because I think it's confusing. I'd say something like, if you got it, go ahead, fast forward me, whatever. But I'd say, all right, I know y is x squared minus 2x, and I'm going to take all of that to the fourth. I know that the f of x, like the outside function, is going to be something to the fourth, and I know the inside function is going to be x squared minus 2x. And then therefore I know that I'm going to need the derivative of this piece, f prime of x, and so that's 4x cubed. And I know I'm going to need the derivative of this piece, that's g of x, and so this is 2x minus 2. And now I'm going to throw it into the chain rule, and the chain rule says this is the derivative of y is going to be f of x with g of x in there. So this is 4 and cubed, but we're keeping this piece, the original g of x, x squared minus 2x. And then at the end, ding, we're tacking on the derivative, oh, sorry, g prime of x. Why didn't you tell me that was there? Like that. Hey, this has to go in parentheses. If it's not, if it's like that, this, as it's written, implies multiply 4 times this mess times 2, do all of that first, and then subtract 2. So it's fussy, but be careful that this is in parentheses at the end, like that. Or else order of operations says do the minus 2 last, and that's not true. Cool? All right. Same sort of thing. We turned this into a fractional notation with a negative exponent, and then you can say this is really just, yes, we described the chain rule again. We said it's the derivative of the outside, so this is the derivative of this piece is the 4 times the derivative of this half multiplies in front, so negative a half, the inner bit, which we'll replace later, and then we decrease the exponent by 1, which gives us negative 3/2. Right? So we take all of that, and then we multiply by the derivative of the inner bit. And the derivative of this is a constant 1, and so our derivative is just the 2. So this is the derivative of the inside. Now let's replace u. We can't replace u, but we can replace u. You know what I mean? And so you should get, oh, okay, so they cleaned up the 2 and the 4 first, and the half. They put all those together and got that. And then we replace the u. All right, so there you go, chain rule. We'll try it out in class, and I'll see you then. Bye.